Hi, my name is John Cornicello, and today I am talking about depth of field and how focal length does or does not factor into how much depth of field you get in a photograph. This is a very basic coverage of depth of field. I'm not going to get into the print size and viewing distances or the math behind calculating the depth of field. To start, depth of field is defined as the distance between the nearest and farthest objects that are seen as being in focus in a photograph. There are two basic controls over the depth of field in a photograph. They are the aperture or f-stop of the lens and the magnification of the subject. Wide open apertures like f2 or f2.8 give very shallow depth of field with just a small area in focus. Closed down apertures like f11 and f16 give greater depth of field. You might be wondering why f2 is a large aperture and f11 is a small aperture. This is because the numbers are actually the denominators in a fraction. f2 is 1 over 2, f8 is 1 over 8. Let's visualize this by using my pizza analogy. f2 is like one of the slices if you cut a pizza into two large slices. f8 is a slice of the pizza when it's cut into 8 slices, or 1/8 of a pizza. It's much smaller than 1/2 of the pizza. Without getting too deep into the weeds, a lens can only focus on one plane in front of it. Everything in front or behind that plane of focus is out of focus by some degree. Things in focus appear as sharp points on the sensor. The out-of-focus objects appear as circles of light called circles of confusion. The trick to all this is that at very small sizes, these circles appear as points to our eyes. So by making the out-of-focus circles small enough, our eyes see these small circles as points and recognize the objects as being in focus. We use the aperture of the lens to control the size of those circles. F-stops vary the amount of light that passes through the lens by opening or closing down an aperture in the lens. Changing the size of the aperture changes the size of the circle of confusion. You can see this in the diagram, how the aperture size affects the circle of confusion. Notice that I have not mentioned the focal length of the lens in relationship to the depth of field. You will hear or read from many people that longer focal length lenses cause shallower depth of field, or that shorter lenses have more depth of field. This is true to some extent, but you need to also know the distance between the camera and the subject. When you combine the focal length and the distance, you get magnification of the subject, and magnification, not focal length, is the other determining factor, along with f-stop over depth of field. Let's go a bit deeper into this. I'm creating this tutorial in the middle of the 2020 COVID-19 situation, so I'm alone in the studio and will use a mannequin head for the demonstrations. Besides, the mannequin doesn't move or change expression, so it gives much more consistency in the photos. I'm going to use two lenses for these demonstrations, a 35mm f2 and a 135mm f2. The 35 is a moderately wide-angle lens on a full-frame 35mm camera, and the 135 is a moderate telephoto, so they make a good pair for comparison. First I will show you a series made with the 135mm starting at f2, f2.8, f4, f5.6, f8, and 11, so you can see how the depth of field changes as I stop down the lens. This next series is made with the 35mm lens at the same camera position and the same range of f-stops. Again, 2, 2.8, 4, 5.6, 8, and 11. You can probably see that for each f-stop the 35mm lens has greater depth of field. Quite simply, if you make a photo with the 135 at a given f-stop and then change to the 35mm at the same f-stop without changing the camera to subject distance, the 35mm image will have a lot more depth of field than the 135. However, you can also see that the subject of the photo is a lot smaller in the frame. Let's concentrate on a pair of images made at f5.6. For these, the camera is locked down on a tripod 3 feet away from the head, with the head 2 feet in front of the eye chart in the background. First is the 135mm, with the focus point of the camera on the eye. At f.6, the lips and nose are acceptably sharp, and the background is clearly out of focus. Change to the 35mm lens and we see the subject a lot smaller in the frame, but the eye chart is much easier to read due to the greater depth of field. If I crop in and enlarge the 35mm photo to match the 135mm photo, you can still see the increased depth of field, but now with much lower image quality due to the loss of resolution from cropping. Here they are side by side for comparison. At this point, most people jump to the conclusion that the shorter lens has more depth of field and leave it at that. But there's more to it. What happens if we decide that the subject is too small in the frame and we don't want the loss of resolution by cropping and enlarging? What if we move in closer with the 35mm lens to about 10 inches away from the subject to make the subject similar in size in the frame as it was with the 135mm lens? Let's take a look. Here is the original 135mm 5.6 image again, and here is the new image made with the 35mm in close. What happened to the depth of field? It is now the same in both images, even though the focal length of the lenses are quite different. The difference is in the magnification of the subject, not the focal length of the lens used. Of course, moving in closer while giving us a similar subject size head vastly changed the perspective of the scene. The chart in the background has become much smaller. That's the topic of another video on my channel. I'll put a link to that in the description. Again, my name is John Cornicello, and I thank you for watching. Take care now.